Hello and welcome everyone to our Introduction to Engineering Final Report video. My name is Tim Phúc. I am the spokesperson of Group 1 Class CC03. I will now showcase the main subject of this video. Its name is PETRA, which stands for PET Recycling Apparatus. We will get into its details later on, but for now, let's meet the group member. NguyenNgocKhanhVy, the group leader. She is responsible for preparing the budget sheet, timelines, and writing official report. Thiện Hòa, the group deputy leader. He is responsible for buying and coding the electric components. NguyenNgocKhan, the main assembler of the mechanical parts of the machine, also takes part in writing weekly reports. Quang Hưng, he also assists in assembling and running the machine. Thiên Phúc, I created the slide and edited the video. I also take part in assembling the machine. Nguyễn, he assists other members with their tasks, and together we created the PETRA. Now let's take a look at the overview. Our video will consist of 6 parts as shown, and we will get into the main ideas of each part in a moment later. Now let's talk about the statement of the project. As all of you know, environmental pollution is currently one of the most pressing issues that confront humanity. Among its primary causes, plastic waste is regarded as a major contributor to this alarming situation. PET plastic, as polymer-related material, are hard to destroy, and their waste is being dumped without being processed en masse each day. So, we want to find a way to recycle it. And during our research, we found out that PET plastic, thanks to its advantageous physical and chemical properties, and especially in availability, can be used as the potential raw materials in 3D painting. Therefore, we want to create a machine that can turn PET bottles into 3D filament fiber that can be used as 3D printing material. It is not only applicable for college student projects, it can be also used as a prototype for industrial level manufacturing. And our solution for all the above is PETRA. PETRA will have 2 objectives as the following: turning PET bottles into 3D filament with specific diameter, preferably 1.75 mm wide. PETRA will also recycle used PET bottles effectively using PID algorithm. We will now move on to the working principle. PETRA utilizing PET polymer characteristic. Polyethylene terephthalate is a type of thermoplastic polymer belonging to the polyester group, widely used in everyday life and industry due to its outstanding properties. PET is also known for its high mechanical strength, excellent resisting to moisture and chemical, and its lightweight characteristic. With all of these properties, PET is an ideal choice for various applications, ranging from industrial sector to engineering projects for students. PETRA also uses PID algorithm. A PID controller is a tool used to control systems so they behave the way that we want it. It helps machine and process reach a desired goal called the set point. In this scenario, it is called the temperature. By adjusting their behavior based on the difference between what we want and what we are getting, this difference is called the error. After calculating the P, which stands for proportional control, the I stands for integral control, and the D, derivatives control components. By programming the code, we can then add them up together to get the PID value, which can correct errors and adjust the speed of the heating system. We now move on to the component. Petra consists of 3 different modules. The first of them being the cooling module. The machine consists of a cooling system designed to provide the necessary torque for the strips. It is connected to the gears that ensure efficient power transmission and precise movement, which is powered by a 12 voltage motor. The extruder module, equipped with a heater, also equipped with a heating tip that provides efficient and precise heat transfer to the PET strips. The heating system is also equipped with a thermistor for precise temperature control and optimal performance. Next up is the microcontroller module. The system is controlled by a microcontroller, specifically an Arduino Nano, which serves as the central processing unit for managing all the component tasks. A stepper motor is also equipped to help operate the device. We also use a variable resistor for fine adjustment, while capacitor and resistor ensure stable operation and protect the circuit from voltage fluctuation. A fan is also added to the system in order to prevent overheating and for final touch. We also included a Petra component start and total expense table in the slide. Feel free to stop the video. We also included a circuit diagram of the microcontroller module. We will now move on to the timeline. From September the 7th to October the 10th, we begin to brainstorm the idea and listing out the components. From October the 15th to October the 20th, we print out the gears and begin to buy the components and assembling the Petra. From October 21st to October 27th, we testing out the motor and the heating system. And finally, on October the 28th to November the 19th, we assemble the machine and begin to fixing problem. We will now move on to the operating process. I would like to showcase you a video to take a look how Petra has been revised to become its best version to its day. Move on to the conclusion. Overall, Petra has its own strength. It can recycle PET bottles into filament, and it can produce filament with 2 mm diameter. However, it cannot replace the original materials. PET bottles have to be cut manually. Heater needs time to heat up and is difficult to operate. Therefore, we have made some recommendations. We should add an autoplastic bottle cutter to reduce the manual labor, and we need to improve Petra to be fully automatic at all phases. And that is the end of our final report video. Thank you for watching.